Geometry folks. So in today's lesson we're going to be going over parallel lines and diving a little bit more deeply into this idea of proofs and giving reasons to the statements that we're giving. And so before we can even talk about parallel lines, we need to kind of define them and define its opposite, right? So in geometry we mainly talk about two different kinds of lines. So we talk about skew lines and we talk about parallel lines. For skew lines, they're lines that are in different planes. And then for parallel lines, they would be coplanar, but they never intersect, so they're on the same plane. So coplanar lines, that never intersect. And that's really the key difference between skew lines and coplanar lines, is that skew lines are not coplanar and parallel lines are coplanar, and they never intersect. So when we're filling out this Venn diagram, skew lines would be that they are both in different planes and they lie in the same plane if they're parallel lines, and for both of them they never intersect. Right? The only difference is what plane they're in. Okay, so let's move on to slide 2. So whenever we're talking about notation for parallel lines, we use a very special notation. So if we're trying to say that line AB is parallel to CD, I could say AB, and if I were to just write this, I would have that double-sided arrow above the AB, but because I'm typing this, it's kind of hard to do, so I'm just going to write AB. And then I want to say two straight lines, and you can find these two straight lines right underneath your delete button or right next to your curly bracket. I want to say that's parallel to CD. So that symbol, those two straight lines, mean parallel. Okay. So why don't we make a mental image to kind of show us what parallel lines really look like. So the parallel rule is that given any line AB and any point P not on AB, there's exactly one line that is both parallel to AB and passes through P. So we need a line that passes through P but never intersects with AB. And so I'm just going to drag this line right over here. And if this were perfectly straight across, then that would never intersect. It was hard for me to kind of make it perfectly straight across, but generally, yes, this line is perfectly straight across. It's never going to touch line AB, and it's going through point P, right? If I were to try to rotate this any other way, so let's say that I wanted it to be like this, right? If we kept extending these lines out, we would see that they would eventually intersect, so they would not be parallel lines. So we really need this line to be perfectly lined up to AB for them to never be parallel. So let's go on to slide 3. So whenever we talk about parallel lines, we can actually form some really cool angle relationships as long as we have a line that's going through our parallel lines. And we call that a transversal. So one way that I can define a transversal is it can be a ray, it can be a segment or line that crosses parallel lines. And so if I'm given this diagram over here, I see that my two parallel lines are AB and CD, and I realize that based on this notation over here, when I have these little arrows on the actual line, I see that those are actually parallel. And so this line that's cutting through is going to be my transversal. So my transversal T is right over here, right? It's this line that's cutting through lines AB and CD. So let's actually move on to slide 4, and let's organize some information that we know about some of the angles that are formed that have special relationships when we have parallel lines being cut by a transversal. So my first angle pair that I'm going to talk about is a corresponding angle. And the biggest thing about them is that they're not going to be adjacent, so they're not going to be right next to each other. They're on the same side of the transversal, and on the same side of each parallel line as well, and they're also going to be congruent when we have parallel lines being cut by a transversal. So an example of this, so let me move 1 over here, right? I'm going to place my angle 1 to be right over here, this obtuse angle over here. And so if I am matching the corresponding angle to angle 1, right, I want to use this description, so it's not going to be adjacent. So it can't be this angle, or this angle, right? So I'm looking at these 4 angles over here. It's on the same side of the transversal, so I'm only looking at these two angles, right? And it's on the same side of each parallel line. So because angle 1 on this parallel line is on top of my parallel line, my corresponding angle will be on the other parallel line on top of it. So my corresponding angle is going to be right over here, right? There are multiple answers for this, right? You could have had it so that angle 1 was right over here. So angle 2 would then be right over here, right? This would be the corresponding angle. You could have had it so that angle 1 was here, so then angle 2 would have to be here. You could have had it so angle 1 was here, so angle 2 would have to be here. But I'm going to just do it so angle 1's there and angle 2's there. Any of those work. And we know that both of these angle measures, right, angle 1 and angle 2 are going to be congruent because we have parallel lines. So that relationship is going to remain the same on both parallel lines. Okay. Let's look at alternate interior angles, right? So let's say I'm going to just list that this is going to be my angle 1, okay? So I want to pick the alternate interior angle to angle 1, and I want to look at my description for it. So I know that my alternate interior angle to angle 1 is not going to be adjacent to angle 1, so it can't be here, it can't be here, and I know that it has to be inside the parallel line, so it can't be this angle either, because only these 4 angles where I place angle 1 here, here, and here are going to be interior angles. They're inside the parallel lines, right? And another thing that I want to note is that it's going to be on the opposite side of my transversal. So the only other interior angle that's not adjacent, that's on the opposite side of the transversal, is going to be right over here, and that's where I'm going to place angle 2. So this angle here and this angle here are my alternate interior angles. Because we have parallel lines, they're going to be congruent. If we do not have parallel lines, none of these angle relationships are going to be congruent. And then finally, I have consecutive interior angles. So I know that they're not going to be adjacent. They're going to be on the same side of the transversal, inside the parallel lines, and supplementary. So I want to pick my interior angle, so I'm going to place angle 1 here again, because that's one of my interior angles. I could have placed angle 1 here as well. Sorry. I could have placed it here as well, but, you know, it's just personal preference. So I'm just going to place angle 1 where I had it before. And then I know that I want to be on the same side of my transversal and on the inside of my parallel lines. So the only angle that's on the same side of the transversal and inside the parallel lines to angle 1, that's not adjacent to angle 1, is going to be right over here. So that's where I'm going to place angle 2. Right? And so angle 1 and angle 2 are supplementary, right? And they're consecutive interior angles. Once again, this relationship only holds because we have parallel lines. If we do not have parallel lines, we cannot say these same statements. So let's actually practice identifying some pairs of corresponding angles, alternate interior angles, and consecutive interior angles. So for corresponding angles, I'm going to start off with angle 1. So angle 1, and I want to look on the opposite parallel line, so L2, and I want it to be in the same position as angle 1 is on L1. So I see that angle 5 is in the same position, so angle 5 is my corresponding angle to angle 1. Let's go to angle 2, okay? If I'm looking at angle 2, right, it's outside of my parallel line. It's on top of my parallel line, right, for L1. So I need something similar for L2, right? So this is on top of my parallel line for L2. And it has to be on the same side of the transversal as well. So I have angle 2 and angle 6 are going to be my corresponding angles. I'm going to move on to angle 3, right? It's below parallel line L1. And so it's on the right side of the transversal, so I need an angle that's below L2, that's on the right side of the transversal, which is angle 7. And then for angle 4, it's on the left-hand side of my transversal underneath L1, so I need an angle that's on the left-hand side of my transversal that's below L2, so that's going to be angle 8. So angle 4 and angle 8 are congruent and corresponding. My alternate interior angles, right? I want to look inside my parallel line, so I only have 4, 3, 5, and 6. So I'm going to choose 4 first. And then of those 4 angles that I highlighted, I want to pick the angle that is on the opposite side of the transversal and not adjacent to angle 4. So I'm going to pick angle 6. So angle 4 and angle 6 are alternate interior angles. So that leaves 3 and 5 as the other alternate interior angle pair. And then finally, for consecutive interior angles, I want to once again focus only on 4, 3, 5, and 6, but I'm going to stay on the same side of the transversal. So if I pick 4 as my first interior angle, my consecutive interior angle to it would be not adjacent to 4, so it can't be 3. It's going to be on the same side of the transversal, so I'm looking at angle 5 as my consecutive interior angle. Now I'm going to choose angle 3, and same kind of thing, same side of my transversal, and not adjacent to angle 3, so I'm looking at angle 6. Okay, so now we actually want to solve for some of the missing angles. And we want to use our angle pairs in order to actually solve for these missing angles. And so this is where talking about proofs comes in handy, because we're actually giving a justification for how we find our missing angle measurement with our knowledge about angle pairs. So I'm going to look at this given angle, this angle of 121 degrees, and I'm going to compare it to angle this missing angle that I have here that's labeled x degrees, right? So I need to figure out what is their angle relationship, what's their angle pair relationship, and how can I leverage that information in order to help me find my missing angle measurement. So when I look at this given angle and angle x, I see that they're actually on the inside of my parallel lines and they're on the same side of the transversal. So I know that my angle pair is going to be consecutive interior. And I know that consecutive interior angles are supplementary if I have parallel lines. I'm assuming that these are parallel lines because this is what we're talking about in our unit. So in order to figure out what my supplementary angle to 121 degrees would be, I would do 180 minus 121. And that is going to give me, what is that, 59? So this is going to be 59 degrees. And let me just highlight my answers so that I know for sure that's what I'm talking about. Okay. Let's go on to our next slide. So we have angle 2, right? And we want to find the angle pair relationship between our given angle 110 degrees and our angle x, right? So I noticed that they're both on the same side of the transversal, but they're not both within the parallel lines, right? So they're not both inside the parallel lines, right? But I noticed that 110 degrees is on top of this parallel line, and angle x is on top of this parallel line as well. So they're in the same position with regard to their parallel line. So I know that these are going to be corresponding angles. And I know when we have parallel lines, corresponding angles are congruent. So if this is 110 degrees, this is also 110 degrees. Let me just highlight that as well. Okay, and then our last problem. We want to see the angle relationship between these two angle pairs, so angle x and this given angle, 60 degrees. So what I noticed is that they're both inside the parallel lines, but they're on opposite sides of the transversal. So I know that these are going to be alternate interior angles. And if I have parallel lines, I know alternate interior angles are congruent. So if our given angle is 60 degrees, angle x is going to be 60 degrees as well. Great. Then we have our last slide, right? So now we just kind of want to ask questions so that we know exactly how to tell if two lines are parallel, right? So this is the thought process that we should be thinking whenever we're trying to determine whether or not two lines are parallel. Okay, so we can always draw a transversal or a line, right? When I'm talking about transversals, I'm talking about lines that intersects the two lines that I'm trying to analyze. So I'm looking at a transversal or a line that intersects the two lines that I have. And then once I draw that transversal, I want to ask myself certain questions. So I want to see, are any two corresponding angles congruent? Because if they are, then you have parallel lines. Are any two alternate interior angles congruent? Same kind of thing. If they are, then you have parallel lines. And then are any two consecutive interior angles supplementary? Because if they are, right, if the answer to any of these questions is yes, then the two lines are going to be parallel, right? So you want to look for your angle pair relationships, and you want to see whether or not they're congruent or supplementary, because if they are, then they're going to tell you that your lines are parallel. And when your lines are parallel, then you do have these very special relationships that we saw on slide 4. So hopefully this was helpful to you. If you have any questions, make sure that you're reaching out to me, and good luck with your practice problems.